Hey, everybody, and welcome to another episode of Software Defined Everything, the podcast for smart world systems. And today I'm joined by George Iglesias of Medacuity, as well as our very own Fran Porcel of RTI. Let's kick things off with some quick introductions. George, do you want to start us off?
Hi, I'm George Iglesias with Medacuity. Thank you for inviting me to this podcast. It's a pleasure to be here. I've been in the MedTech space consulting for about 25 years, mostly Class 2, Class 3 devices. I work for Medacuity as a solutions architect, where we have been helping a number of customers over about the past decade with their regulatory submission and strategies and architectures for Class 1, 2, and 3 medical devices. And we also support a plethora of customers in the robotic space as well.
Sounds good. Thank you for joining us today, George, and thank you, Stephen, for having us. My name is Fran Porcel. I'm a principal application engineer here at RTI. I work in the professional services department. I've been working here for over 8 years now, and what we do in professional services is to train our customers on the product on RTI Connext. We also help them architect it and debug it at times. So it's been a fun journey.
Thank you both. It's a pleasure to have you both on the podcast. George, can you tell us a little bit about Medacuity and the partnership with RTI?
Yeah, Medacuity is a consulting services house that we consult with many clients with their medical devices, and we usually do a lot of architecture work for them. And in those architectures, we always find a need for a data messaging solution or a way to share information and data across different systems, because many of these systems are complex that we deal with, especially in the latest breadth of devices we see, they're getting even more complex. And we always find a need for a data solution service, and we find RTI's DDS system and services the best in class, and we usually recommend first and foremost in all our projects.
Yeah, that's a good way to put it, George. I've had the opportunity to work with Medacuity and a couple of common customers a couple of times. And I see our partnership as, when you need to build a house, you will hire a general contractor. In this case, that would be Medacuity. And then the general contractor then needs to look into who can provide the best pipes. And we need to look for plumbers. So that's a bit of where RTI comes in. RTI provides both the pipes, which in this case is RTI Connext, and we also have some really good plumbers in our professional services team. So we complement each other really well. And at times one couldn't really work without the other.
So as our listeners may know by now, our discussion today is around teleoperation in the MedTech space. For those who are new to the subject, teleoperation has been around since 2014 with somewhat limited usage, but now we're starting to see more excitement in this area. So let's just start with the basics. What is teleoperation? How does it work? And how does it fit into modern healthcare? George, you want to start us off?
Yeah, so I think before you can discuss teleoperation, you have to talk about what is the current state of many surgically assisted robotic surgeries these days. And what you have is typically a surgical console, and you have a patient side cart with a robotic arm. And usually these are connected by a closed network, maybe within the room, in the adjacent room, or in a hospital campus. These systems have been around for quite some time. Teleoperations seeks to extend the reach between the surgical console and the patient cart with the robotics arms on them across a region, across a country, across the globe. That's really the focus of it. So it's really just leveraging that expansion of where that network fits in and what the scope of that is.
Yeah, I agree with that. I think that in terms of teleoperation, some of the normal needs of, you have your normal surgical robot that is already working with the surgeon next to the robot. Some of those needs get amplified. Like now you need to really have an emphasis on monitoring, controlling, viewing the applications, regardless of their location or network, things that you may not have considered in the past now come into play. The way I see robotics is as a distributed system of systems, and with teleoperation, we're just increasing the distances between those systems. Now, it is going to require interoperable, reliable, and secure communications to make all of that possible.
Agreed.
After hearing both of your responses, I think it's clear that this is a very complex technology. What are the key requirements for the design of these systems? Fran?
Yeah, I think that it is important for the all the devices that are now part of this larger system to be interoperable with each other. They are all going to need to communicate, and low latency and reliability are going to become really critical because when you had the surgeon sitting next to the patient and next to the surgical robot, latency is something that you take for granted with modern networks with 1 gigabit Ethernet or even sometimes 10 gigabit Ethernet. You can not even consider latency at that point. But when you increase the distance between the surgeon and the robot, sometimes maybe the surgeon could be in New York, the patient and the surgical robot may be in Texas. Now, the latency is going to be depending on the speed of light, and it is going to become more meaningful. It is going to go from the order of nanoseconds and microseconds to the order of milliseconds. And that increase is going to be really critical. So you need some technology that can help you with that. And of course, cybersecurity. Cybersecurity is going to be key now that you're not depending on just a local area network where everything is very controlled. Now you are going to have to depend on an internet service provider that may or may not cover your cybersecurity needs. So you may need to design around that as much as possible.
How about you, George? What are your thoughts on the key requirements of the design of these systems?
I think Fran covered a lot of the salient points there. I think the other points that Medacuity usually deals with are now that you have a system that works on a closed network, and as Fran explained, you're extending that network reach, what happens to your safety risk profile? What happens to your safety mechanisms? And how do you compensate for those in your system? What architectural changes do you need to make to deal with these new latencies, data drops, line drops? You're working over a third-party network that you don't have any control over. So some of the key things we're looking at here are video compression. Is all this to really minimize latency, video compression, VPNs, different technologies, hardware VPNs on each side of the house. All these technologies are used in place to eliminate some of that risk associated with this now increased latency and the effect on your safety risk.
Building on top of that, George, can you give us an example of how teleoperation would generally work?
How it would generally work? As explained before, so think of a system that exists already in a hospital, a setting, where the doctor and the patient are actually very close to one another. They may be in the same room, outside the sterile field, in the next room, or maybe in another building on the campus. Teleoperation seeks to now separate that by a larger region. And what they're really trying to do is take the surgeon's hand movements and eye coordination and feedback that the surgeon has over his instruments and now extend those over a network into the robotic arms and mimic those gestures and movements that the surgeon is making, essentially extending their reach and their knowledge, what they see and how they interact with what they see across the vast, vast network.
Yeah, I agree with that. If we consider teleoperation being a system of systems with a lot of distributed applications, devices, components, integration of different multiple applications, communication is going to be really important there. But the OR integration itself and the automation capabilities of the surgical robot now are going to become really key to cover the gaps of that new trend of teleoperation, because the feedback loop is going to be more critical. So the use of AI for intraoperative guidance or decision support is going to become more and more relevant, and we're going to have to do the AI more at the edge than before.
What are some of the biggest challenges and considerations in teleoperation and telesurgery? What are the big challenges that are holding us back? George, what are your thoughts on this?
I don't really think there are any real technical challenges holding us back. I mean, the state of the art of technology today is we have robots that you can OEM for medical surgical robots that you can OEM. You have video compression technologies. You have hardware VPNs. You have a more mature network communication schemes other than ATM. That was when the original teleoperations networks were put in place for the first surgical robotics. All these things are key players in moving the technology ahead, and these systems have been well integrated. I think some of the issues that we've been seeing is really around non-technical issues more so than technical issues. And going back to the safety risk I mentioned, is that what is the safety risk of not being able to communicate with that robot? What not being able to have that video feedback to in a timely manner to the surgeon performing the surgery? Because ultimately, the surgeon is doing the surgery, not the robot. And I think in all these architectures Medacuity works on, we look at DDS and the QoS especially to help reduce this safety risk by tuning the messaging system, tuning the feedback of these messages in a way that we can leverage those systems. But I don't really think there's technology challenges ahead of us.
I agree with you, George, there, because I think that we're technically there. Is more about, can the regulation keep up with the technology, and can we develop around that? So I agree that the communication is going to become a key piece, right? That is the part that we're really stretching a lot when we talk about teleoperation. That distance between the surgeon and the patient is going to amplify some of the technical challenges that we used to have, right? We're going to need still a highly reliable, low latency, and secure data exchange between all the applications. So connectivity is going to be the core to these technologies that are driving these systems. Now, in terms of cybersecurity, as George said, I think that we're technically there. We have all the security capabilities in terms of authentication, in terms of encryption and access control, etc. But we need to adapt to the guidance that the FDA and the different regulation authorities provide. And that is, I see, where Medacuity can help a lot, because, Medacuity can depend on Connext to provide some of the key pieces of the security for their communication, but they can also help you with things like, okay, how can I make not just my system safe and cyber secure, but the whole company, the whole OEM needs to be secure. And, simple things like everybody, when they connect to their computer, they need to have two-factor authentication. That needs to be part of the cybersecurity challenge that we're going to go through. And that is not necessarily something technical or something that is even part of the surgical robot that is going to be performing the surgery, but the people who are developing it are going to need, for example, that two-factor authentication. So I know that Medacuity can help auditing all of those processes.
Fran, can you give us an example of how connectivity for applications like these should work, and what the best technologies for that would be?
Yeah. So when we're thinking of teleoperation, nobody goes ahead and thinks, I'm going to perform remote surgery thousands of miles away if they don't already have a robot, because they're really building a surgical robot that helps the surgeon perform surgery, to me, is the more critical aspect. You need to have that already available. And then from there on, you just need to stretch the distance between the surgeon and the patient. So for those companies that are building that surgical robot and are thinking of teleoperation, if they are already using a technology like DDS and RTI Connext, they're in luck, because if you have your system already depending on DDS, then you know that DDS is going to be data-centric. It is not going to be connection-oriented. You're really caring about the data and not where the applications are, because DDS discovery is going to help you with all of that. So if I had to address this problem with RTI Connext, I know that I only need to create a couple of new domain participants in the network, and I'm just going to need to tell them, this is where you need to connect, very simply. And Connext, I know, is going to take care of everything for me, and I don't need to maintain a list of servers and addresses and a lot of things that can get really convoluted, because I know that I can rely on RTI Connext and DDS to do that for me.
How about you, George? What's your philosophy on how connectivity for these applications should work?
I think it's critical that you extend what the surgeon is seeing in close proximity to the far proximity. So the technologies we usually deal with are video compression, video exchange, high performance video, 4K video, right? 3D, haptics feedback systems. All those things are really critical. And then we incorporate. But I think when Fran was pointing out, using of a data-centric service, I think Medacuity really likes the fact that And in these examples, if an architecture has something like that in place, using the QoS capabilities to tune things and to manage things makes it much more flexible to adapt your safety risk and mitigate some safety risk through those factors, because you have those levers to pull and to push. These are some of the key technologies we look for when we're doing an architecture with robotics for communications purposes, yes.
George, you mentioned system architecture. What are the other technologies in addition to DDS that are used as a part of this overall system?
Oh, so there's it gets pretty complicated pretty fast depending on the robot, how many movements and arms you have. Usually you have dedicated robotic controllers and servos, and you have dedicated platforms interfacing with them. You have your video architecture. That is who's watching the video, who can see the video, what type of overlays do you have on top of them, of those videos, what type of vision you have, 2D, 3D. These are some technologies that we're seeing moved into that space. But those are just some of the ones we typically see that we typically have to work with. Most of our customers already have the robotics control down. We may help them tune it, move it to an architecture more real time. We help them adapt to different platforms, different hardware, hardware availability solutions come and go. Those are the key things that we look for in an architecture that we plan out on. Well, what's your underlying hardware? Can it be A or B? And so we allow them to adapt to those depending on the architecture that we give them.
Yeah, I can think of some other technologies. I feel that you're going to need some technology that can enable the integration of robotics control, monitoring, also video, AI, and machine learning, and NVIDIA Holoscan can help with all of that. We see some of our customers using MathWorks and some other customers also using MedCrypt to address a cybersecurity challenge. And we see some customers using ROS as well, more in the research and simulation and test use cases, more than to actually put together something a bit more commercial. The good thing is that ROS already has DDS built in, so it can easily interoperate with Connext, but of course, it has limitations because it has that extra layer, that kind of wrapper over native Connext. So we see some customers building sometimes hybrid systems using ROS and Connext at the same time. And sometimes when they need to take that step to a more commercial solution, we see them fully embracing native Connext in the system.
Yeah, so far what I'm hearing is that teleoperation is gaining a lot of traction because the technology is finally caught up to what the vision was in the first place. Fran, can you elaborate on this idea of where we are now as opposed to the vision that we had, a few years back?
Yeah, I think that right now what I see is companies leveraging a bit more a new paradigm, which is make it about the data centricity mindset, where in this mindset, the global data space becomes important. You need to make the data available to the applications, and you need to do that in time. And, this data-centric sort of system, this is already a proven technology for real-time communications across different industries, not just healthcare and medical and surgical robotics, but we have seen Connext being used in the NASA launch control. We have multiple electrical vehicle companies. So at the end of the day, these are systems of systems as well. So some of the benefits of Connext, in addition to what I mentioned earlier of discovery, George has mentioned the quality of service as well, is that Connext is transport agnostic, which I think is a key advantage for teleoperation, because it doesn't matter if you're in your local area network, either wired or using Wi-Fi. The fact that Connext is transport agnostic also helps when you need to move and send that data over the wide area network.
Let's focus on some of the more promising things you've seen. Who's ahead in the teleoperation space right now, and why do you think they are ahead of the game? George?
I think Intuitive's clearly ahead of everyone else, followed probably by Stryker, followed closely then by probably Medtronic. There's a bunch of other lesser players, but I think Intuitive's been there since day one. In fact, that reference 2014 surgical procedure, teleoperation procedure, was done on the predecessor of the intuitive Da Vinci system that eventually came to fruition. So they've had the longest lead time in the controls. They have all the patents. They've been in that space a long time. So from the robotic standpoint and surgical standpoint, they are definitely clearly the leaders in that space.
Yeah, I agree with that. In the medical space, for sure, those companies are ahead, and we see a lot of startups and also bigger players trying to catch up to that. I think that in terms of teleoperation itself, not even in the healthcare spectrum, we see a lot of other players that have been around for many years, like the example of NASA or the European Space Agency, or for mining and underwater sort of navigation. Teleoperation has been key for many, many years. And now healthcare and medical robotics has realized, oh, we should start thinking about the distance between the surgeon and the patient and see what kind of use cases we can enable. So one of our customers, Monogram Orthopedics, they have proven that they can do remote surgery with thousands of miles in between the surgeon and the patient. So I see a lot of use cases now in medical for orthopedic, but I think that for remote stroke use cases, that's going to become really important too, because there are many areas, especially in the United States with such a big country, where more remote locations that do not have access to the big surgical centers, somebody may have a problem, they may have a stroke, and they need to drive a lot of miles so that they can reach an ER. So if we can somehow enable them to have access to the best doctors, the best surgeries, doing them remotely through teleoperation, I see a lot of future in that field.
That segues actually into my next question, which is my final question, by the way, as we wind down here. Fran, where do you see teleoperation heading towards in the next 10 to 12 years?
Yeah, that's a good question. I think that for all the history of surgery, the surgeon has needed to be right next to the patient. Then we introduced surgical robotics into the picture. So we increased the distance a bit between the patient and the surgeon to maybe being in the same OR, or maybe the surgeon is in a different room compared to the patient. Now, we can keep stretching that distance. So we can make it as long distance as we need to in the same country or even across continents. And I think that that is the future, having access to the best surgeons no matter where you are. I am from Spain, so when I was growing up, I would see celebrities traveling to the United States to get the best surgeries, both plastic and, other types of surgeries. So telesurgery in that situation would have enabled everyone to get access to the best care, not just the people that can afford it, the wealthier people. So I think that the future in the next 10 years, by increasing that distance between the surgeon and the patient, would be to enable the best care for everybody.
George, what are your thoughts on that?
I agree with Fran. I think also that the availability of OEM product to create a surgical system, has developed so much so that you have players now who would never have considered creating a robotic arm, just OEM it, who never considered a 3D visual feedback system. They OEM it because the concept is different. So now you're having more innovation in this area about what to use and what to do. And with the fact that you can now extend those over a broad region, separating provider from patient, you now have all this innovation being accessible more globally, right? Taking limited resources, doctors, and applying them to global needs, patients. So I think that's a good direction and a positive direction I see going. And I think it's just going to increase as time goes on, as the technical challenges and OEM challenges and barriers to entry to the field, they get lower and lower every year, actually.
We certainly have a lot to look forward to in the next 10 years.
Yes.
Well, with that, we conclude this episode of Software Defined Everything. I want to give a special thanks to George Iglesias from Medacuity and Fran Porcel of RTI for joining us and sharing their thoughts on the podcast today. We certainly covered a lot, and it was a pleasure to have both of you on the podcast.
Well, thank you for having me. It was a pleasure being with you. Thanks for being with us, Fran, too.
Thank you, Stephen, for having us, and thank you, George, for joining us today.
Thank you.